In a remarkable discovery that sheds light on the evolution of planetary systems, scientists have managed to observe a star system that's roughly 200 million years old, right at the cusp of its formative teenage years. This system, known as TOE 2076, has given researchers a unique glimpse into what happens as planets transition from their early volatile stages into more stable adult configurations. For a long time, astronomers have understood the broad strokes of how planetary systems are born and how they appear as they mature. Yet, the intermediate stages, what you might think of as the awkward teenage years of a planetary system, have remained largely elusive. That's where TOI 2076 comes in. This system consists of four planets, each ranging in size from about 1.4 to 3.5 times that of Earth. These planets are classified as sub-Neptunes, which are larger than Earth but smaller than Neptune, and intriguingly, this type of planet doesn't exist in our own solar system. TOI 2076 orbits a relatively young K-dwarf star, which is about 210 million years old, just a cosmic teenager itself. The study of this system has provided scientists with invaluable insights. It offers direct observational evidence that the dynamic reshaping of compact planetary systems begins early in their lives and continues over time. The research highlights an interesting pattern in TOI 2076's planets. Initially, they were likely locked in a tight gravitational dance, a state known as mean motion resonance, where planets exert a gravitational pull on one another in a stable, repeating pattern. However, as the planets evolve, they begin to drift apart, losing that synchronization. The current state of TOI 2076 shows that its planets are no longer fully locked in resonance. Instead, they're in a fragile state of near resonance, slowly moving away from each other like dancers who have just stepped out of sync. To gather this information, scientists utilized data from NASA's Transiting Exoplanet Survey satellite, also known as TESS, along with observations from ground-based telescopes. They meticulously measured the sizes and orbital periods of these planets. The findings revealed a nearly consistent pattern in their spacing, suggesting that they were once tightly resonant. But the story doesn't stop there. The researchers also delved into the atmospheres of these planets, discovering a fascinating correlation between their proximity to the star and their atmospheric composition. The innermost planet has lost its hydrogen and helium atmosphere entirely, leaving behind just a rocky core. The three other planets further out retain varying amounts of their gas envelopes, with the second planet holding on to about 1% of its mass in hydrogen and helium, while the next two maintain around 5%. This clear trend supports a process known as photoevaporation. Young stars emit intense radiation, which heats the upper layers of a planet's atmosphere. If the radiation is strong enough, gases can escape into space. Thus, planets that are closer to their star receive more radiation and lose more of their atmospheres. Over the first few hundred million years, particularly within the first 100 million years, this stripping process can lead to the complete loss of an atmosphere or reduce it to a scant layer. To confirm this explanation, the study authors created computer simulations that assumed all four planets started with similar rock-to-gas compositions. They simulated how stellar radiation would erode these atmospheres over time, and the results matched the actual observations of TOI 2076 closely. The simulations also indicated that as planets shed gas and mass, their gravitational interactions change slightly, pushing them further out of exact resonance and increasing the distance between their orbits. Howard Chen, one of the study's authors and a professor at Florida Tech, expressed the excitement of seeing their models align with real-world observations. It's an incredible validation of their hypotheses and a powerful insight into the processes at play in such a young planetary system. Finding a planetary system in this adolescent phase is no easy task. This period is relatively short compared to the multi-billion-year lifespan of stars. Most systems that astronomers observe are either very young or long settled into their adult forms. TOI 2076 provides that crucial bridge, allowing scientists to witness firsthand the processes of orbital reshaping and atmospheric stripping as they begin. However, it's important to note that TOI 2076 is just one system. To fully understand if this pathway is common across the galaxy, researchers will need to study more planetary systems of a similar age. The team plans to apply their updated models to other young systems and continue searching for more signs of atmospheric escape. The findings from this study are published in the journal Nature Astronomy, marking a significant step forward in our understanding of how planetary systems evolve. The more we learn about these cosmic teenagers, the clearer the picture becomes regarding the life cycle of planets and the dynamic processes that shape them. As we continue to explore the universe, discoveries like that of TOI 2076 remind us of the intricate and often turbulent journeys that celestial bodies undergo, from their birth to their eventual maturity.